Now, let's say you came across this question in your upcoming Jamb, and you have these three questions. What are you going to do? This question is actually under the topic of AC circuit. Now, I would implore you to stick with me till the end of this video because I have a bonus for you at the end of this video. Now, which of the following statements is correct in an AC circuit containing a resistor? Which of these statements is correct in an AC circuit containing a resistor? So in a purely resistive circuit, what do you have? Now, current leads voltage, so meaning across the resistor by a phase difference of 90 degrees. So what I say is just that current voltage lags current. Is that true? No. In a purely resistive circuit, you know, the part of the circuit that we say is passive is the resistor. And why do we say? So resistor is a passive electrical component. It's passive because it doesn't use up energy. What it does to the energy or the voltage that is supplied is that it converts it to what? Heat energy. It doesn't use it up. It doesn't, work is not done on the resistor. Do you understand now? So it converts the voltage. So because of that, current does not lead voltage, neither does voltage lead current. So the option B says reverse of A. That is voltage is now leading current. Now, current is in phase with voltage across the resistor. That will be the answer. Is that okay? That is why there is a we said that voltage and current will be in phase. Voltage and current will be in phase. This one says current lags voltage by phase difference. This means phase difference of 180 degrees. Now, I wanted to mention the fact that there are now two other type of circuit that we have. I will call them purely inductive and purely capacitive. So in a purely inductive, now what will happen is, now look at what I will use to represent. Now purely inductive, inductance is represented by L, and purely capacitive, capacitance is represented by C. So for purely capacitive circuit, the current will lead. Do you see that? CC, current will lead by 90 degrees, will lead the voltage by 90 degrees. An inductor, the voltage, you see that if I turn L, it will look like V, right? Okay, so that's how to remember. The voltage will lead by 90 degrees. Voltage leads current by 90 degrees in a purely inductive circuit. Current leads voltage by 90 degrees in a purely capacitive circuit. And of course, in the video I posted on my channel, I told you why that is so. Voltage is leading here because there is eddy current, that eddy current acting in the opposite direction. Then current is leading here because voltage is first stored up on the plate of the capacitor. So if you want to get it, just subscribe to my YouTube channel and check out the videos that I've released there on AC circuit. Now, the next one is the opposition of an inductor or capacitor to the flow of alternating current is called what? So if it is inductor or capacitor, the opposition for resistor, the opposition to the flow of current is called what? Resistance. Yeah. So this is out of the case. So now this is because it says or, we know that capacitors or inductance cannot be the answer. So the best option, in fact, if you didn't even know it, that should come to your sense that okay, capacitor, should come in. Capacitor is capacitance, inductor is inductance. Is that okay? So the opposition to the flow of rendered by inductor and capacitor is called reactance. For capacitor alone, we call it capacitive reactance. Inductor alone, we call it inductive reactance. Then the last one says calculate the peak value of the mains supply of these 240 RMS. So this is a formula we basically use, that VRMS is equal to the peak value over square root of 2. And we're looking for peak value. So what does that mean? It means that peak value is equal to root 2 times VRMS. So V naught will be equal to root 2 is about 1.414 something, then times 240 volts. So to show me that you stuck to the end of this video, multiply this and tell me the answer in the comment section. Now it's a very simple question. Look at this. This is 1.14. This is above 1, right? If it's above 1, your answer must be above 240. This is not the answer. This is not the answer. This cannot be the answer. So, all right. Now, so just make sure you drop the answer in the comment section. The bonus I said I had for you was this. I'm going to be doing a 7 days wrap-up a 7 days Jamb series. Is that okay? We'll be studying most of what you need, if not all. I'm believing God that we're going to study all the topics that we need for physics, Jamb physics, and now it's going to happen on my YouTube channel. So do well to subscribe to the channel before that time. God bless you as you do so.